Kirloskar Group of companies was one of the earliest industrial groups in the engineering industry in India. The group produces pumps, engines, compressors, screw and centrifugal chillers, blasts, and electrical equipment such as electric motors, transformers, and generators. It's the world's largest genset manufacturer. The company exports to over 70 countries in most of Africa, Southeast Asia, and Europe. Kirloskar brings forth a high-quality assortment of Kirloskar pumps. These pumps are manufactured with high-grade raw material and sophisticated technology in compliance with set quality norms. Tensile strength, elevated durability, efficiency, and reliable performance are some of the attributes defining these pumps. Kirloskar pumps are highly used in air conditioning plants, power stations, as well as mine drainage, lift irrigation, sprinkler systems, firefighting, booster service, pumping brine, alkaline solutions, oils, benzene, and others. We know that pumps are used for water, sewage, heating, ventilation, air conditioning, and refrigeration systems, pressure-boosting hydropneumatic systems, firefighting requirements of infrastructure, construction, residential buildings, multiplexes, housing boards, shopping malls, etc. When a company is manufacturing pumps, it must be clear about the function where the pump is required. If the company is not aware of the function required for the pump, is it possible for the company to fulfill the client's requirements? Hello all, and welcome to this lecture on pumps used in construction, where we will understand how pumps are used in construction and what operations are performed by them. After the lecture, we will be able to learn the following objectives. Understand the equipment for dredging and trenching. Define dragline, clamshells, and tunneling. Explain the equipment for drilling and blasting. Discuss pile driving and erection equipment. Explain the equipment for dewatering, grouting, and demolition. Let's start with a brief introduction of pumps used in construction. The heart of most process industries is the pump, because in almost all the process industry, liquid is to be handled through various vessels, storage tanks, heights, and lengths during the process of operation. Keys to pump selection are pump startup problem and time, operating problems, future maintenance problems, operating and maintenance cost, process reliability, low energy consumption, service conditions, space problem. Let's discuss the equipment for dredging. Dredging is a process that involves the aquatic excavation of waterbeds to remove sediments, pollutants, shellfish, and other materials. Dredging serves 4 general purposes. It's performed to create or deepen waterways to allow large ships to pass. Dredging is used to catch seafood. It's performed in the attempt to remove pollutants. Dredging can also be used to remove desired materials from the waterbed, such as minerals. Types of dredging equipment. Dredging equipment can be divided in mechanical dredgers and hydraulic dredgers. Mechanical dredgers are bucket ladder dredger, grab dredger, dipper and backhoe dredger. Hydraulic dredgers are plain suction dredger, cutter dredger, trailing suction hopper dredger. The bucket ladder dredger. The bucket ladder dredge or bucket chain dredger is a stationary dredger which has an endless chain of buckets carried by the so-called ladder, positioned in the well of a U-shaped pontoon. Working method. The bucket ladder dredge is positioned on 6 wires. Under working condition, the dredge swings around her bow anchor. The bow anchor line or headline can have a length longer than 1,000 meters. Area of application. A bucket dredger can be applied in almost all soils, from soft silt and clays to soft rock depending on the power and the strength of the bucket chain. They are used in blasted rock as well. Grab or clamshell dredger. The grab dredger is the most commonly used dredger in the world, especially in North America and the Far East. It's a rather simple and easy to understand stationary dredger with and without propulsion. Working method. For grab dredgers, the amount of anchoring and the positioning system plays an important role for the effectiveness of the dredger. At every pontoon position, an area as wide as possible will be dredged. Areas of application. Difficult accessible places in harbors. Small quantities with strongly varying depth. Along quay walls where the soil is spoiled by wires and debris. Borrowing sand and gravel in deep pits. Did you know the hydraulic crane was invented in Newcastle by William Armstrong in about 1845 to help load coal into barges at the quayside? Plain suction dredger. A plain suction dredger is a stationary dredger that positions on one or more wires with at least one dredge pump, which is connected to the suction pipe and the delivery pipe. Working method. The working method is based on the breaching process, and the erosion is created by the flow near the suction mouth, generated by the dredge pump. Breaching is a process of soil shearing on a slope caused by local instabilities or by erosion of the density current running along the slope to the suction mouth. Area of application. Due to the lack of cutting devices, this type of dredger is only suitable in non-cohesive soils. Furthermore, this method excludes accurate dredging work. Dredging under offshore conditions is possible with special equipment. Types of plain suction dredgers. There are different types of plain suction dredgers, such as barge loading suction dredger, used when the transport distances are too large for direct pumping. Standard plain suction dredger discharges the material direct via pipeline to the reclamation area. Deep suction dredger. This dredger is equipped with an underwater pump. Cutter dredger. The cutter suction dredger is a stationary dredger equipped with a cutter device or cutter head, which excavates the soil before it is sucked up by the flow of the dredge pumps. Working method. The rotating cutter excavates the soil during their movement, generated by the side winches, from port side to starboard and vice versa. Applied working area. Cutter suction dredgers are applied for dredging harbors, channels, reclamation areas, and so on. The transport distance of the mixture is limited to maximum 10 kilometers. It's very useful when the accuracy of the works is important. Trailing suction hopper dredger. The basic options of a THSD are one or more suction tubes provided with suction mouths or drag heads, which are dragged over the seabed during dredging. One or more dredge pumps to suck the material from the seabed. A hopper in which the dredged material can settle. Easy operational bottom doors or valves in the hopper to dump the dredged material. Working method. When arrived at the dredging area, the speed of the vessel is reduced to about 2 to 3 knots, or 1 to 1.5 meters per second, where the suction tubes are lowered to the seabed and the dredge pumps are started. When the suction tubes reach the seabed, the swell compensator reacts, which is easy to see by the movement of the hydraulic cylinder. Applied working area. The THSD is a free-sailing vessel and does not hinder other shipping during dredging, and it's therefore ideal for dredging in harbors and shipping channels inshore as well as offshore. The seagoing vessels are very suitable for borrowing sand under offshore conditions, wind and waves, and large sailing distances. Trenching is a form of excavation in which a large hole is dug. The hole itself is usually quite deep, but not very wide, and it's often dug to be long. Trenching is common in construction, especially when installing underground pipes, wires, or structural supports. Types of trench equipment. Trench equipment generally refers to any sort of tool or device that may be used for constructing a trench. This can include something as simple as a backhoe or shovel, or more heavy-duty earth-moving machines, like a rock wheel and chain trenchers. Let's now discuss dragline and clamshells. A dragline excavator is especially useful when there is a need for extended reach in excavating, or when material must be excavated from underwater. Clamshell excavators provide the means to excavate vertically to considerable depths. Pontoon-mounted pumping. The pontoon-mounted pump dredger consists of a large submersible pump suspended from a pontoon and dunked into the seabed. The advantage of the pontoon pump is that it's capable of a larger output than any other dredger of comparable size. The disadvantages are rough seas, especially swell, hampers this kind of dredging due to the fact that the pump does not always contact the seabed. The range of sediments which can be dredged efficiently is very limited. Trailing suction. When dredging large volumes of cohesionless sediment, a trailing suction dredger is normally used. A trailing suction dredger is a hopper vessel with a trailing arm suspended over the side and dragged over the seabed. The advantages of trailing suction dredgers are minimum interference to sea traffic, versatility in handling both cohesionless and cohesive sediments. The dredged load may be pumped ashore as reclamation. Constructed in various sizes to suit most project sizes. The disadvantages are the final dredged depth is less precise, necessitating some over-dredging, and mobilization costs can be considerable. Clamshell bucket. A clamshell bucket is seen frequently near construction sites. Just as the name suggests, it's made up of two sides that open and close like the shell of a clam. The custom-made 1,000 tons and 150-meter-long machines are giant underground factories that are not just for tunneling, but also removing the muck and creating a sealed concrete tunnel as they go. Each machine has a rotating cutter head at the front and a series of trailers behind, housing all the mechanical and electrical equipment required for the excavation of material. There are also smaller boring machines that can be used to dig small holes or tunnels into walls or rock. These are handheld units and typically dig holes a few feet in diameter. Now let's explore the equipment for drilling and blasting. When thick layers of rock or isolated rocky outcrops need dredging, blasting is an efficient method of excavation. In this method, a series of closely spaced holes is drilled into the seabed, charged with explosives and fired. Selection of hole diameter. The first step in the process is to determine what hole size or diameter, bearing in mind that this could change over time as the operation grows and matures. This is probably the most important single factor since it will, in large part, determine the size, quantity, and type of drill or drills that are needed. Required production. If intended actual production is 1 million tons, to choose a medium-sized rotary drill rig that is capable of drilling a 200 millimeter diameter hole and producing 3 to 5 million tons per year on a single shift operation would be excessive. Type and size of excavating and hauling equipment. Some are of the opinion that because large excavators and haul units are employed, the blast hole should be as large as possible and the drill pattern spread, since larger sizes of blasted rock can be handled. Bench lift or height. If there is an existing bench height, then selection of the blast hole size has to be made with this in mind. In some areas, legislation has dictated maximum heights so that some of the selection process has been eliminated. Drilling methods. Percussion, drifter or out-of-the-hole drills, OHD. Air actuated, hydraulic fluid actuated. Down-the-hole drills or DHD. Rotary, blade or drag bit rotary drilling. Roller cone bit rotary drilling. Percussion drilling. Drag or blade bits. The drag or blade bit has fixed wings that penetrate the rock and gouge it out. Some of these bits are supplied with replaceable blades. Roller cone rotary bits. Roller cone, or sometimes referred to as tri-cone or rolling cone bits, are the most utilized for blast hole drilling. Truck mounted. This type of mounting is really an adaptation of a water well rig. Its obvious biggest advantage is speed of mobility between sites and drill areas. Track mounted. This configuration overcomes most of the disadvantages of the truck mounting, except it's less adaptable for rapid deployment between drilling areas or job sites. Blasting. Blasting is an area that has come under very strict scrutiny in the post-9/11 work environment. Blasting is heavily regulated and watched by federal and local agencies. Fragmentation. In the 1990s, increasing emphasis was placed on the role of fragmentation of the operation. In particular, the effect of fragmentation on crushing, load and haul, and run-of-mine leach pad efficiency has received considerable attention. Explosives. The past 15 years or so have seen new explosive formulations reach the marketplace and reductions in the use of some products that have been in use for longer periods. Emulsions. The formulation of an emulsion is very similar to that of blasting slurries or water gels. However, the cross-linking agent used to stiffen the slurry is replaced by an emulsifying agent. This water and oil emulsifying agent suspends minute droplets of the ammonium nitrate oxidizer with the fuel. Dynamite. Dynamites are used as decoupled charges in pre-splitting. They are also sometimes used to prime ANFO in small diameters. Explosives and blast initiation accessories. This means the product can be efficiently detonated by a blasting cap or delayed detonator of adequate strength, or by compatible detonating cord. Detonating cord. Detonating cord contains a core load of high explosive. It detonates at about 22,000 feet per second. Shock tube systems. The shock tube system is a plastic tube with a thin explosive coating on the inside of the tube. Upon detonation, this material continuously detonates at a low velocity of approximately 6,500 feet per second. Electric detonators. Fewer blasts in surface mines and quarries are initiated with electric systems today than once was the case. However, this practice is certainly still followed by many, especially in quarrying. Electronic blasting systems. Electronic blasting systems are unique as they have eliminated the pyrotechnic delay element and replaced it with a high accuracy timing chip. pile driver is a piece of construction equipment used to install piles, which are a crucial part of the foundation of large structures. Pile hammer. A pile hammer is a device used to drive concrete and steel pilings into the ground, to be used as support for building projects. Equipment and methods. The types of hammers used on the selected contracts are a single-acting diesel, a double-acting diesel, and a single-acting hydraulic. Now let's talk about erection equipment. The goal of ensuring construction erection work is to reduce the proprietary risks arising in the way of construction work and restore the pre-loss situation in the case of a loss event. Erection towers are simple structures that are commonly employed at building construction sites. Crane. Cranes are machines that use levers and pulleys to lift significant weights. The ones that a person might pass on the road may look like a fairly modern invention, but these machines have actually been used for at least the past 2,000 years, if not longer. Groundwater can be controlled by means of one or more types of dewatering systems appropriate to the size and the depth of the excavation, geological conditions, and characteristics of the soil. Sumps and sump pumping. A sump is merely a hole in the ground from which water is being pumped for the purpose of removing water from the adjoining area. They are used with ditches leading to them in large excavations. Well point systems. A well point is 5 to 7.5 centimeters diameter metal or plastic pipe 60 to 120 centimeters long, which is perforated and covered with a screen. The lower end of the pipe has a driving head with water holes for jetting. Shallow wells. Shallow wells comprise surface pumps which draw water through suction pipes installed in bored wells drilled by the most appropriate well drilling and/or bored piling equipment. Deep wells. When water has to be extracted from depths greater than 8 meters and it's not feasible to lower the type of pump and suction piping used in shallow wells to gain a few extra meters of depth, the deep wells are used and submersible pumps are installed within them. Now let's discuss the equipment for demolition. Demolition hammers are tools which are designed to be utilized in demolition. They are typically heavy and powerful so that they can be used to break up a variety of substances, from wooden walls to concrete pads, and they are an important part of the tool arsenal for a construction crew. The most basic demolition hammer is a standard hammer with an especially large, heavy head and a long handle. The user can generate tremendous force with the long handle, and the head packing a serious punch which can break through a wide variety of materials. Now in the end, let us summarize what we have learned in this lecture. Dredging is a process that involves the aquatic excavation of waterbeds to remove sediments, pollutants, shellfish, and other materials. The bucket ladder dredge or bucket chain dredger is a stationary dredger which has an endless chain of buckets carried by the so-called ladder positioned in the well of a U-shaped pontoon. A plain suction dredger is a stationary dredger that positions on one or more wires with at least one dredge pump, which is connected to the suction pipe and the delivery pipe. The cutter suction dredger is a stationary dredger equipped with a cutter device or cutter head, which excavates the soil before it's sucked up by the flow of the dredge pumps. Trenching differs from simple hole digging because a trench is generally not as wide as it is deep. It's also usually very long rather than isolated in one area or built in a circular shape.